Hello everyone, welcome to day 29 of 30 days LeetCode challenge. Today we are going to solve jump game problem required to determine whether you can reach the last index of an array given that each element represents your maximum jump length at that position. So in this problem we will have an array of non-negative integers nums and you are initially positioned at the first index of an array. Each element in the array represents your maximum jump length at that position. Determine if you are able to reach the last index. So for solving this problem, we will use greedy approach. The idea is to keep track of the furthest index that can be reached while iterating through the array. If at any point the current index is greater than the furthest reachable index, return false. And if the loop completes, returns true. So let's take an example to understand this approach more. So let's take the first example where we have an array 2, 3, 1, 1, 4. So here we will initialize I to 0 and furthest to 0. So at 0th index the element is 2. So we will do 0 plus 2 which is 2. So here the maximum is 2. So we will update the furthest value to 2. Now we will increment the I value. So I will become 1. So 1 plus 3 will be 4. So 4 is greater than 2. So we will update the furthest value to 4. And the 4 jumps can reach us to the last index. So the loop breaks early and it returns true. Now in the second example, 3, 2, 1, 0, 4, we will initialize I to 0 and the furthest to 0 like previous example. At first index is 0 plus 3. So our furthest will update to the maximum value that is 3. Now we will increment I value so it will become 1. So now 1 plus 2 is 3. So it means the furthest will remain 3. Again we will increment the ith value. So now I will become 2. So now 2 plus 1 is again 3. So the furthest value will remain 3. Now we will increment ith value again and it will become 3. So 3 plus 0 is again 3. So the furthest will remain 3. Now the index will become 4 and the furthest value is 3. It means the I is greater than the furthest value. So that's why we will return false. So now by keeping these two examples in mind, let's start coding. So as we see in the example, we will first declare the furthest variable and initialize it to 0. Now we will have a for loop which will iterate through each element of a nums array. The for loop will start from I is equal to 0 till nums.length. Now we will update the furthest by comparing maximum value between the furthest and I plus nums of I value. So for that we will use maths.max. But before that we will have an if condition which will check if I is greater than furthest. If it is, then we will return false as we have seen in the second example. Now after that we will have an if condition which will check if furthest is greater than or equal to nums.length minus 1. And if it is, then we will return true. And at last we will return false. And now let's check if everything looks fine. And let's try to run the code. And it's working. Your greedy approach will help us to keep track of the furthest index that can be reached and we can efficiently determine the reachability. The time complexity of this code is big of n, where n is length of an input array. And the space complexity is big of 1. That's it for today's explanation. I hope you found it helpful. Stay tuned for more problem solving insights tomorrow. Happy coding!